In this tutorial, we're going to talk about the next section, 7.3, sum and difference formulas, specifically for sine and cosine. And we have a rule in particular that we're going to follow, and this is what it is. So this is what it's going to look like. So when I take one sine function and a cosine function and we're adding the functions together, the only way that we can do this is if the periods are the exact same. So the b's have to be right on the dot exactly the same in order to do this. If not, you can't do it. It's the same idea as adding like terms. So now that I know what I'm looking for, over here on the right hand side, this capital A, in order to get this, we do the square root of let's see what this is. This is a squared, or a1, so our first a term squared, plus a2 squared. So that's how we come to get the capital A. And in order to find this guy right here, our horizontal shift, or our theta, we're going to follow tangent phi equals a2 over a1. And this, of course, is going to help us practice our inverse trig as well, because once again we have an unknown theta value. So let's take a look at an example. So here's our example. This is example number 2 on page 313 of your textbook. And here's what it says. We have a function, its name is g of t, and it says that it is equal to 2 sine 3t plus 5 cosine 3t. And then it says write g of t as a single sine function. So I want you to know that we need to check our periods first. And when I check them right here, they are the exact same. So I can use this rule above to help me find this out. So just like what the rule says, I should end up with a function that looks like this. A sine of bt plus phi, or phi. However you want to pronounce it is fine. So in order to find capital A, I have to do this square root business. So I'm going to start setting that up. So capital A is equal to the square root. So A1 is the coefficient of my first part, which would be 2. And I'm going to highlight that in orange. There it is. So 2. And I'm going to square that, and then I'm going to add that to A2, which is 5. And we're going to square that as well. So that gives me the square root of 4 plus 25, so that's 29. And since that's a prime number, I'm going to leave that just as it is. So we now have A. So I'm going to go over here and I'm going to substitute in square root of 29 for A. And I'm going to write sine. Now BT is the B that we started with, like our like term, which was 3T in red. So I'm going to copy that down right here. That's not going to change. Plus phi. Now we have to go in and find our theta. So tangent phi equals A2, which was 5, over A1, which was 2. And when I use my inverse trig, that should yield phi to be, let's see here, and we should have 1.190. So over here, that's exactly what I'm going to write. So 1.190. Note that when I did the inverse, that this number right here stands for a radian measure. Okay, so just make sure that you know that. So this would be my final answer. This is my g of t function as one function. All right, so let's take a look at what else we have. So let's take a look at a problem like this. This is something else out of this section. And we're finding exact values for values that are not on our unit circle, values that are not easy to find. So in this case, it's like the sine of 75 degrees. Well, on your identity sheet, the colorful one that I handed you, you should see 4 different sum or difference formulas. And we're going to use one of them for this. So the one that I'm going to use is the sine of theta plus phi equals the sine of theta cosine phi plus cosine theta sine phi. And this is just one identity that we have, and you're not going to know which one to use right off the bat. Sometimes, once you get better at these, you'll be able to know a little bit easier which ones to use. But I'm going to help guide you through this. Instead of using the one here where it says theta minus phi, but everything else, like the sine of this, would equal something different, okay? I'm going to tell you that that's not the one that we're going to use because I want to guide you through this a little bit quicker. So here's what we want to do. We want to break this 75 degrees down into 2 values that are on our unit circle. So in other words, I could write this as the sum of 2 different measures that equal 75. So take a second and see if you can figure that out for yourself, or pause the video. Give yourself a minute to see if you can do it on your own. Okay, so here's what I'm thinking. I'm thinking we do 30 degrees and 45 degrees. Okay, now is this the only option that I could do? Absolutely not. There are several different ways of going about this problem. This is the most straightforward and the simplest. So we're going to go ahead and follow this rule. So I'm going to do sine of theta, which I replaced with 30. So sine of 30 degrees times the cosine of phi, which is 45 degrees, plus the cosine of 30 degrees. Oops, that's not plus, that's some multiplication. Times sine of 45 degrees. So here's how we're going to simplify this. We're going to only use our exact values because in the instructions it wants an exact value. So stay with that the whole way through. That way when you get to your answer, you'll be good to go. So sine of 30 degrees is 1/2. The cosine of 45 degrees is the square root of 2 over 2, plus the cosine of 30 is the square root of 3 over 2, and sine of 45 is also square root of 2 over 2. Alright, so let's go ahead and get this simplified, just multiplying a couple fractions. So 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. The square root of 3 times the square root of 2, when you multiply radicals, you just multiply what's underneath them. So 3 times 2 is 6, and then 2 times 2 is 4, and this whole thing can be written as one fraction as the square root of 2 plus the square root of 6 over 4. And that's my final answer. That is what the sine of 75 degrees is going to equal. So there you go. That's going to conclude this tutorial. This is just a basic guide through of your formulas. So you've got 4 to choose from, so now it's up to you to decide which one to use and when.